Okay everybody, so this video is going over the work I did in the Google Hangout earlier this morning that most of you weren't able to attend. So you will see what you missed and be able to continue doing the work, okay? So what we're looking at now is a continuation of some stuff that I've done previously. I've already put up one video explaining how this stuff works, but this is going through some of the specific questions from the book. A secondary recap, if you will. It's exercise 19.6 of your book, Quadratic Sequences, okay? Now, for those of you who never bothered to bring your books home when we shut down the school, I will be uploading a picture of the pages of the questions as well so people can do it, all right? So, first of all, quick recap, what is a quadratic sequence? So, a quadratic sequence is a different type of sequence to a linear sequence, okay? So, if we look here at an example, I've got a bunch of numbers, 4, 9, 16, 25, okay? And so I want to identify what type of pattern is this. So what we were doing in class previously was you get the difference between any two numbers. So the difference between 1 and 4 is 3, 4 and 5 is 9, 9 and 16 is 7, 16 and 25 is 9. So our first difference is a bunch of different numbers, okay? 3, 5, 7 and 9. Now in the previous questions, linear patterns, these numbers were the same because it was going up by the same amount each time. But if you look closely at these numbers, what you will spot is these numbers are going up by the same amount each time. So this, what is called our second difference, sorry by the way of the board, it's hanging from my kitchen wall, so it's a bit difficult to write on. Our second difference is the same. And if the second difference is the same, it is a quadratic sequence. Okay, so that is how you prove if a sequence is a quadratic sequence or not. You find your first difference, the difference between any two numbers, see if it's the same. If it's not, you see is the second difference between any two numbers the same. Okay, so that's how you get a quadratic sequence. Now, if I wanted to find the next number in the sequence, I can work my way backwards. So the second difference for all of these is 2, okay? So that means if this number here was 9, well, the next number here would have to be a difference of 2, okay? And a difference of plus 2, not minus 2. So 9 plus 2 is 11, okay? But if this number is 11 and this number is 25, the number here has to be a difference of plus 11. So 25 plus 11 is 36. Yeah? And I could continue going on. We have a difference of 2, and our number here is 11, plus 2 is 13. We have a difference of 13, plus 36 is 49. And that is how we can actually find the numbers in a quadratic sequence as well. So if you're given, say, 3 or 4 numbers and told, find the next 3, 4 terms in the pattern, the first thing you do is get your first difference, see if it's the same. If it's not, get your second difference. If it's the same, we now know it's a quadratic pattern, and we can work our way backwards to find the next terms in the sequence. So now let's look at a couple of questions. Question 1. The nth term of a sequence Tn is equal to n squared plus 3. What does nth term mean? Guys, nth term is just another way of saying the general term, the general formula. This is my general formula per sequence. When we're doing our linear patterns, we're using an s instead of an n. But the letters don't matter, okay? So it's a general formula with which I can find any terms in a sequence. And I'm asked to find the first 5 terms. So all I do is sub in. First term, I sub in 1 for n. 1 because it's the first term. 1 squared is 1 plus 3 is equal to 4. Second term, sub in 2 for the second term. 2 squared is 4 plus 3 is equal to 7. T3. 3 squared is 9 plus 3 is equal to 12. Okay? T4. 4 squared is 16 plus 3 is equal to 19. And T5. 5 squared is 25 plus 3 is equal to 28. Now if we were asked to prove the distal quadratic sequence, we would now find our differences. So the first difference, 7 minus 4 is 3, 12 minus 7 is 5, 19 minus 12 is 7, 28 minus 19 is 9. Well, our first difference is not the same. In other words, these numbers are not going up by the same each time, which you can tell from looking at them, so it's not linear. But let's get our second difference. 5 minus 3 is 2, 7 minus 5 is 2, 9 minus 7 is 2. Our second difference is the same, so it is a quadratic sequence. So let's look at question 2. And I'm actually going to do question 2 part 3 here. 2n squared, tn is equal to 2n squared minus 1. Find the first 4 terms in this sequence. T1. Okay, so 1 squared is equal to 1. So the sum now becomes 2 times 1 minus 1. Well, 2 times 1 is 2 minus 1 is 1. T2. Okay, so now remember BIMDAS, whichever you call it. That's how you figure out how to do this, okay guys? So you always do a power before you do anything else. 2 to the power of 2 is 4. So the sum now becomes 2 times 4 minus 1. 2 times 4 is 8 minus 1 is 7. T3. 3 squared is 9. So the sum is now 2 times 9, which is 18 minus 1 is 17. And then T4. 4 squared is 16. So it's 2 times 16 minus 1. 2 times 16 is 32 minus 1 is 31. Now they haven't asked us to do this, but we're going to do it anyway because we're good math students. Prove that this is a quadratic sequence. We get our first difference. 7 minus 1 is 6. 17 minus 7 is 10. And 31 minus 17 is 14. These numbers are all different. It's clearly not going up by the same amount. It is not linear. However, these numbers are all going up by the same amount, 4. So, it is a quadratic sequence. I want you to do the other 2 questions for me. 2 part 1, 2 part 2. Now let's look at question 3. Part 1. Find the first and second difference between the terms of the sequence, hence state if the sequence is quadratic. 3, 4, 6, 9, 13. First difference. 4 minus 3 is 1. 6 minus 4 is 2. 9 minus 6 is 3. 13 minus 9 is 4. The first difference is not the same, it is not linear. But we can all see these first differences are all going up by 1, so therefore we've proved it is quadratic. Question 3, part 2 and 3, do them for me as well. Question 4. Part 1. By examining the pattern in the first differences, write down the next 2 terms in each of these sequences. 6, 8, 12, 18, 26. So let's get our first difference. 8 minus 6 is 2. 12 minus 8 is 4. 16 minus 12 is 6. 26 minus 18 is 8. And our second difference, as we can all see, is 2. So the second difference is 2 and this number is 8. This number has to be 10. And if this number is 10, 10 plus 26 is 36. Okay, we're asked to get the next two terms. So we do it again. Well, the second difference is 2. And we know this number is 10. So what number must this be to have a difference of 2? Well, 10 plus 2 is 12. And if this number is 36, then what is this number so that there's a difference of 12 between these two numbers? 36 plus 12, if we remember 12 times tables, is 48. So there's our next two terms. Do for me question 4, part 1. Question 5. Now I'm not going to do this whole thing out, but I'm simply going to show you how you would do it, okay? So we've got a diagram made of matchsticks. Actually, I'll draw this a bit lower down. So. Okay. So diagram 1, we have 1, 2, 3 matchsticks. Diagram 2, we have 1, 2, 3, 4, 5, 6, 7, 8 matchsticks. Diagram 3, we have, well, there's the 8 here, plus 9, 10, 11, 12, 13, 14. Yeah? 8, 9, 10, 11, 12, 13, 14, 15. Sorry, I thought I'd counted that wrong. Okay? So, how do we get the next one? You just continue the pattern. So the first thing we do is draw the number of matchsticks we had here. So that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then you continue the pattern. So we draw another 2 here, another 2 here, another 2 here, and our new top layer. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And here, folks, is our pattern. 3, 8, 15, 24. You will use these numbers now to find the first and second difference so that you can figure out how many would be in number 5. You might say, sir, can I not just draw the picture? Well, no, that's a waste of time because once we figure out the numbers, we can work it out much quicker than drawing a picture, okay? And in another class, I may show you all how to get the general formula for this, okay? So, question 5, do the whole thing. And now, before we go on, I need to show you one more example, so you can also do questions 6, 7, and 8. So let's look at these numbers. 2, 4, 8, 16, and 32. Take a minute to look at these numbers and see can you identify their pattern. They don't go up by the same amount each time. And if we try to get the first difference, that's 2, difference of 4, a difference of 8, and a difference of 16. The second difference is a difference of 2, a difference of 4, a difference of 8. It is clearly not a quadratic pattern. And by the way, if you were asked to identify the pattern, if you did this and simply said it is not quadratic, that might be enough to get full marks. But what type of pattern is it? Okay? Hopefully someone has realized that this is being doubled effectively each time. Okay? Or it's 2 to the power of n. So if we go through our terms, 2 to the power of 1 is 2. 2 to the power of 2, our second term, is 4. 2 to the power of 3, our third term, is 8, and so on and so forth. This is what we call an exponential sequence. Okay? So an exponential sequence is always going to be one where it is x to the power of n. Okay? And that's what they want you to do in questions 6, 7, and 8. In question 6, write down the next 3 terms, figure out what is the pattern. Question 7, write down the first 6 terms in the sequence 2 to the power of n. So you're just doing what I did here. 2 to the power of n, first sequence is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. And then just use your calculators. By the way, if you don't know how to do this with your calculator, hopefully people can see this, it's this button here, the x to the power of square. If I want to write 3 to the power of 7, that is how I do it. X with a square in the top right equals 2,187. Okay? And question 8, write down the first 4 terms in it. It's the same thing again, we just sub it in. For question 8, do it properly, write it exactly as you would in your calculator. So it'd be 3 bracket 2 to the power, to the power of 3, bring it down, close your bracket, equals. I hope this came up in your calculators. Have a look at them. To do any power other than squared or cubed, it's the x to the with a box in the top right over the sign button. Okay. So what I want you all to do for me is finish up the question 8. I've also, folks, uploaded a video on my YouTube channel for the next section, graphing of a linear pattern. You are to look at that video and you are to start attempting all the questions in the next section for me as well for Monday. All right? Thanks a lot, and remember to wash your hands.